Now I'm going to present the group about the stability of floating body. My name is Arif Imran bin Ikhwat Razi and my group Navin Raj and Muhammad Fazli. So I'm going to talk about the abstract. So the purpose of this experiment is to determine the height of metacenter using tilting method. The example of the problem is the floating of a boat on the surface of space. We want to know its stability by using the tallness of each focal point of floating. In this experiment, the height of metacenter will be determined using the tilting method. The result can be compared to the calculation.
Assalamualaikum warahmatullahi wabarakatuh. Today we are gonna learn about the stability of floating body. There are three objectives that we can achieve from this experiment, which are to determine the height of metacenter using the tilting method. The second one is to determine the stability of a pontoon with a center of various height. The third one is to determine the understanding of the floating bodies. Alright, before we go through, we must know about the stability of floating body. Any floating body consists of two forces, which are the downward and upward forces. The downward forces is the weight of the object, whereas the upward forces is the buoyancy force. The weight is acting at the center of the gravity G, and the buoyant force is acting at the center of buoyancy BO. W and Bf are always equal, and if these forces are collinear, the body will be upright position as shown below. So it means the body will remain same and it not move. The body may tilt from many causes like wind or wave action, causing the center of buoyancy to shift to a new position BO prime as shown below. What is the meaning of this statement? The meaning of this statement is if there are something like wind or wave disturb the system, the center of buoyancy can be changed to the new position. On the left hand side, M is above G. That means the floating body is a stable position. And at the right hand side, M is below G, which means the floating body are unstable position. The stability of the body, such as ship which float in the surface of a liquid, is one of obvious importance. Whether the equilibrium is stable, neutral, or unstable is determined by the height of the center of gravity. And this experiment, the stability of the pontoon may be determined with its center of gravity with a various height. So one shown there are stable and unstable equilibrium. That means if the greater the metacentric height, the greater the stability. However, very large metacentric height causes the undesirable oscillation in the ship and are avoided. Alright, a comparison with calculated stability also can be made. A floating body is stable if it tends to return to original equilibrium position after it has been tilted through the small angle. Next, let's move on to the theory of the stability of floating body. The knowledge of the stability of pontoons, such as floating ship, is important. The height of the center of the gravity determines whether the ship is stable, unstable, or in a critical condition. In this experiment, with the center of the gravity at the various height, the stability of the pontoon can be determined. Other than that, with the calculation method, the result can be obtained from the experiment and can be compared. Next, we move on to the calculation based on the theory. Overturning couple. The formula is C naught equal to WGX. C naught is overturning couple. W is the mass of the horizontal weight. G is gravity. X is distance which the horizontal weight is moved. The second one is righting couple. CR equal to WGGM. The second one is righting couple. CR equal to WGGM tan theta. Capital W stands for the total mass of pontoon with vertical height. GM is a height of metacenter. The third one is for equilibrium C naught. CR, then GM equal to WX, W tan theta. Next, The area of second moment formula, Vm equal to I over V. Vm stands for the length between the center of the body and metacenter. I stands for the area of moment at water surface. V is the volume of the space where I equal to LV3 over 12. L is the length of fountain and V is the width of the fountain. And the last formula is V equal to total W over rho. Capital W stands for the total mass of fountain with a vertical height. And rho is the density of water, like usually, like usual. And V and the last okay. And the last formula is V equal to W over rho. W is the total mass of fountain with vertical height, and rho is the density of water. Okay. Therefore, Gm equal to Vm minus Vg. Vg can change it to y plus V over 2, which are y is the distance between base of fountain and the center of to the center of the gravity, and d is the distance which the horizontal weight is moved. Thank you.
Good morning. Now I'm going to explain about methodology. Basically, methodology consists of apparatus used and experimental procedure. The apparatus used were pontoon, pillar with horizontal vertical weight, ruler, pontoon stabilizer, and water tank. Experimental procedure. This is what's supposed to be conducted. The horizontal weight was removed and the height of the vertical weight was fixed on the mast of the pontoon. The center of gravity Cg was determined by putting the pontoon mast on the pontoon stabilizer. The length of Cg, which is the half distance from the base of pontoon to the center of the vertical weight, was measured. The horizontal weight was fixed and the thread was ensured to be at the 0 mm position. The tank was filled with water and pontoon was placed in it. The length of the pontoon, which is submerged in the water, was measured. The horizontal weight was moved 10 mm and the angle of tilt of the thread was recorded. Step 6 was repeated by moving the horizontal weight to the right with 10 mm increment. The angle of tilt was recorded. This step was repeated until the bob was hanging on the thread touched the side of the pontoon. Step 6 and 7 were repeated by moving the horizontal weight this time to the left. The height of vertical weight was adjusted to the new height and step 1 to 3 followed by 5 to 8 were repeated. The test was done for two different values of vertical height. Basically, the pontoon, the weight was placed at the top, middle, and the bottom. Okay, these are the data which are given: the mass of horizontal weight, total mass of pontoon with vertical weight, width of pontoon, and length of pontoon. Okay, 3 tests was conducted, 3 different CGs, and 3 different diameters. Throughout the calculation, I measured everything in mm, still can be calculated in meter. Okay, I took left hand side as negative and right hand side as positive. Okay, our first discussion will be on graph of GM versus theta for each test. We can see that the first test, which is CG 132 and diameter 25 millimeter, it has a curve. It is more curved compared to test 2, which has CG 104 millimeter and diameter 26 millimeter. In test 3, it is more stiffer compared to test 2 and test 1, which has a CG of 80 mm and diameter of 27 mm. We can conclude that the experiment with CG of lower CG at bigger diameter have a stiffer graph compared to bigger CG and smaller diameter. Okay, our second discussion will be the value of GM from the plotted graph when theta equal to 0. Uh, from, from the graph, we can take the equation and implement and substitute the value when x is equal to 0. For the first test, GM will be 36.625 mm, second test will be 60.39 mm, and third test 81.947 mm. This is experimental procedure. When we calculated through theoretical, which is with formula, our results is different. For first test, it is 80.7 mm, second test is 109.2 mm, third test is 137.7 mm. We can see that from experimental and theoretical, our values are different. This is basically because of the errors occurred during the experiment. According to the test, the obtained results from the area of second moment and the graph are different. The theoretical values from formula and the experimental value from the graph are different due to the possible errors occurred during the experiment. Okay, one of the possible error could be happen is maybe the thread wasn't at 0 mm position, which is the third point. If it is not at 0 mm, it will affect the position a lot. Okay, the third discussion will be discussion of reliance of meta center on the position of center of gravity in term of stability and floating body. Meta center M is depend on the position of the gravity. The floating body is stable when meta center is above the center of gravity. As the meta-centric height distance between G and M increases, the stability increases. Vice versa, the floating body is unstable when a meta-center is below the center of gravity. This will be our last discussion. Discuss the effect of variation in angle of tilt of the position of meta-center. From the equation, Gm equal to Wx over capital W tangent theta, the small w will be mass of horizontal weight and capital W will be total mass of pontoon with vertical weight. The angle plays a big role on the position of the meta center. We can see the angle affects a lot with the results. When we use different angles, we have a different GM, which basically shows that the angle affects the GM a lot. It gives a very big impact. GM, which is directly proportional to 1 over tangent theta, the smaller the angle, the larger the value of GM. Thus, more stable the floating body is. That's all from me. Thank you.
Now to talk about the conclusion. So this study determined the height of metacenter using the sensing method. Our data shows that if the center of gravity decreases, the height of metasensing increases. The data obtained is slightly different from the theoretical value. This is due to the error that we need to avoid. We need to avoid parallax errors such as in taking the point of reading and the environment, such as when wind or temperature. You can always repeat the measurement and take the average to avoid random error.